Hey, welcome back. We are on a Friday afternoon stream, but it is Friday for Marko in Europe. So Friday afternoon for Marko. It's the morning in the US. And we're back with another live stream where we go over things about Golioth. This week, we're going to be going over Embedded World, where Marko and I were just at. And Mike's got some stuff on the firmware side of things. How you guys doing?
I'm good. Are you guys all caught up on sleep from the 12 hours of standing in a conference hall and talking about geeky microcontroller cloud things?
I think we are.
I'm missing it, you know. Now I just sit in my office by myself, not talking. I mean, I'm talking to you guys, but I'm not talking to like a range of people and getting like interesting new things happening. So yeah, I'm in withdrawal personally.
Marko, this was your first time at Embedded World, right?
Yeah, it was.
What was your impression?
I knew it's big, like a big event, a big conference, but I didn't know that it was. I think last year there was 27,000 people in 3 days, which is a lot. And Wednesdays are a bit hectic. Like there's a lot of people on Wednesday.
Yeah, it really does slow down at the end of the show, but yeah, that middle day.
When did it run? Was it like Tuesday, Wednesday, Thursday?
Yeah, that's right.
Yeah. And in Nuremberg, Germany.
Mike, you're saying this like you don't know. You were there last year.
Leading questions.
Leading the witness, Your Honor.
So, Marko, the thing that I really liked about it, and one of the reasons I always wanted to go to it, is it's like a ton of engineers around. Like I've been to other shows where it's like more of the business side of things, and you're talking about deals and sales and stuff. But like I always was excited to hear what people were working on. Did you have a similar experience?
Well, yeah, everyone there is an engineer, and there's not a lot of sales folks. For me personally, it was really nice to connect names to faces. When you're chatting with someone over the email, or even if you have a call, it's not the same as meeting them in person. And it was quite a lot of fun to be at the Zephyr booth and speaking with our folks about Zephyr. There was a lot of interest in Zephyr, to be honest. And speaking Golioth and catching up with all the current users, potential future users, and our design partners.
We just released a video of Marko showing off the air quality monitor, and he did a great job with that. We're going to release some more demos from around the Zephyr booth. We've had some other stuff on LinkedIn. It's tough because like so many people are doing stuff at Embedded World, so we don't want to just do a recap. Like this is our recap, right? But we actually wanted to showcase like the hardware we're doing, some of the people we talked to, things like that. When we talked to one of our partners, I think that video is coming out soon. So we'll have more videos on the proper YouTube channel. I think some of the stuff will go in shorts too. And then you get to hear from us here. So by the end of next week, when all the stuff's out there, people will be thoroughly sick. They're like, all right, enough with the Embedded World. And then we'll come in with all our returning people from Embedded Open Source Summit, which is just wrapped up yesterday. So you guys, it's like a mini conference season. It's like everything's happening in April, and then it's like the desert for all summer.
It's a 2-week marathon.
Yeah. Some people did it too. Some people flew from Nuremberg, Germany, all the way over to Seattle, where they're back-to-back weeks. We didn't do it this year. None of us went to the other one, but
yeah.
We do have 3 folks at.
Yeah.
I think some of the Zephyr guys went like back-to-back Embedded World and
that's right. Mm-hmm. Yep. Yeah. So, yeah. I mean, we talked to a lot of our partners there. Marko, did you see anything while you're walking around? Anything new?
Well, to me, everything was new.
Oh, sure.
But
like new technologies that you haven't seen elsewhere, though. You know, like that's the big thing.
I didn't perceive things as new because I read a lot about new stuff coming out on embedded.com, for instance. But I always like new shiny tech, so I was always drawn to stands that had oscilloscope or similar things.
Yeah, that's good. I saw there was like it's like everyone was making the motion towards like AI stuff, and I just what a snoozer. I would rather watch Trond do the high-end AI stuff like on the last stream rather than.
Yeah, Edge AI was a term that was used a lot there. Like it seems like everything is moving to the edge or embedded device. So like
Yeah, that's
sensors,
true. Yeah, I guess
data processing, especially.
every time you'd walk by
Yeah.
a camera, you'd see a box around yourself. How about that? Everybody wants
So
to
the
put a
trends
box
are
around people.
shifting. The trends are shifting.
Yeah. Yeah. Well, let's catch up with Mike on the SDK first, and then maybe we could shift back to some of the demos, because I'm trying to recreate a demo on my bench as we do this stuff too, because I sent all my demos to Seattle. I was gonna be like, oh, I could show stuff here. Oh, no, all my hardware is in Washington currently. So
I got to
Mike,
get the
what's been going
list up here. So we did release version 0.12.0 of the Golioth firmware SDK, and that comes out with a whole bunch of new samples in the ESP IDF side of things. So if you've seen the Zephyr side of things, we kind of do these granular samples all throughout, and we've been adding the same granular samples. So each one of them shows off a service. So like time series data or stateful data or over-the-air updates or settings or RPC, and we're filling all those in so that there's kind of parity between the two. And the really great thing for me personally is we're adding hardware in the loop tests as we add all of these. And so like every time we do a release process, it gets a little bit easier to test everything. Also with this one, we added, and we announced it on Tuesday, support for the Rack 5010 board, which is running the QuickTel BG95 modem. And I got to do a ton of fun stuff with that one. If you've been following Zephyr closely, you know that they had a modem subsystem that was released like 6 months or so ago. And that modem subsystem is based on something called chat scripts that sends the AT commands to the modem for you. And I get to really dig into that stuff. And it's pretty clever. There's not much documentation on it. So I think, Chris, we should probably do like a series of posts on kind of like getting into the guts of that. But the gist of it is, if you have
one thing we should call out first is that it is not, as I first thought, I thought Mike was like chat script, like using GPTs or something like that. He's actually...
It's not even like a separate script. Like it's just like macros inside of the driver file, which was confusing to me. Yeah.
Right.
Maybe, I don't know.
It's like a set of AT commands. Is that right?
Maybe, I don't know. I gotta learn more about it. It seems like some people already know about it, so maybe it's used elsewhere. This is not a new thing. But I think the gist of it is, if you have like a cell modem or any modem that's running AT commands that's not supported by Zephyr, and you know how to use those AT commands, you should be able to set this up yourself to use the modem subsystem just by kind of like sequencing the commands. And it's kind of cool how it's set up, because in addition to sending the command, you can then send like a filter for what comes back from that command, and then assign a callback to that filter. So it's pretty extensible in that way.
I feel like that's one of the things about it generally is like AT, obviously AT commands, Hayes modems are like 50 years old at this. I mean, like when did those start? Like the 70s? I don't even know. It was like early modems were using AT as well. And so it's just been ongoing for years and years and years, right? But every time you got to go re-implement this stuff and like write your own custom things. And at least if there's some infrastructure around it now, it should just be hopefully should be.
Ooh, little frozen there. We're gonna have to wait for the hopefully part. The thing that made Chris's head spin, I think, is I told him that I didn't think the chat scripts were that bad of a system. Like they worked pretty well for me. The thing that I had a problem with is the documentation on the QuickTel command set. Like I found some commands in like a different app note that weren't in the AT command set, and like those were the commands that I needed for the thing I was working on. But other than, I mean, come on, embedded, it's always like that one piece of information that you're searching for, and you find it and it unlocks everything. So I think it was fine.
There he is.
I don't want to be here anyways. This is the second time that's crashed. I think maybe I've got too many browser windows open.
Oh no.
You know, we just put out so much content at Golioth that I'm just, I think actually it was because I was editing video earlier, and like my poor little laptop video card is just like, I can't take it.
Let's see, rounding out the firmware SDK. So we have a new sample on the Zephyr side that shows DTLS socket offload for NRF91 devices. And that's pretty cool. So one of the things that you can do with that is store your credentials in the secure key store of the 9160 and then use the socket offload to pass those to Golioth when you authenticate. And in that way, like you can write the certificate to the device, but you can't read it back, but you can use it. It's pretty neat.
Yeah, that's something we had interacted with some folks on before, right? Because they wanted to use the hardware. Like there was some offloading for like battery perspective, but then also some secure storage of the credentials, right? Wasn't
think
Jared
so.
doing some of that stuff? I remember like Jared had a sample at one point where we were putting. I just remember
Right.
encoding PSKs.
Yeah.
In that weird format that then went into the storage into that storage area.
Yeah, you have to hex encode the PSKs and then put them in that storage area. I did a post. I'll find the post and flash it up on the screen at some point. I'm pretty sure I did a post showing this off, and it's kind of neat. I mean, there are TLS credential tags that tell you like what type of tag it is, and so like you can store, like credentials. For PSK and credentials for certificate, both in that area, and you can store them you can store multiple credentials at different places. So if you want to do key rotation or credentials for different things, it's a useful system.
It's one of those things where you don't think about it until you're kind of in the depths of it, right? I mean, like you're really got production stuff out in the world. Key rotation is a really key thing. You know, like it's always possible, but like until you're actually thinking about it, you're not like it's not first in mind. You know, it's more like, oh, I just need to send data right now. It's like, yeah, but you just wait, buddy.
Yeah.
Mike, is it possible to like delete keys or add new ones?
Yeah, and you can do it at runtime as well. So if you have a system where you're somehow, I suppose what you can do is encode your credential. I mean, it's always like, how do I send the new credential to the device, right? But you can encode the credential locally, send it over Golioth to the device, and then when it gets written to the key store, you could decode it using the existing. I suppose it would already be encrypted going across Golioth. I'm just thinking, like, do you want to send your new device credential, unencrypted through? So I think, yeah, there's a whole Pandora's box of choices there.
Right. That would be a different PSK. That'd be a post-shared key, right? Instead of a pre-shared key.
That's right.
Not the best. Yeah. So I think there is some care needed at that point, but I think there's more flexibility allowed.
Yeah, let's see. There's a long blog URL for you right there.
Oh yeah, tags. Yeah, that's in the chat, at least on YouTube. I thought you were going to flash it up like the actual window, but yeah.
Oh, I could flash the actual window if you want.
Sure. It's okay. It's okay. That's cool. So, Mike, how do you think people will be using this in the short term? The ability to use the key storage area, or sorry, the offloaded.
Yeah. Well, I think if you're using an NRF91, you should definitely use certificates in the key store because it's going to be the most secure thing. I mean, in general, if you have a device in the field and someone gets a hold of it and they get the certificate that's on the device, they can only access that one device, and then they can't really read information, right? So they could send erroneous information to your back end if they went in and read the bits of the chip. But in general, you do want to use certificates if you can at production. I think one of the only reasons I can think of not using certificates is if you have a device that is so resource constrained that it just can't do the math, the cryptography for the certificate, then you might go with pre-shared keys. But once you're using your certificates, if you have a secure key store available, that's always the best way to do it. I mean, in production, it's nice because you could write directly to that key store, so you don't even have to have I think you can write directly to the key store. I don't know, I have to actually check on that one. I was thinking you don't even actually have to flash the firmware in order to write to the key store, but that might not be right. You might need to have some intermediary steps. So maybe you would do a power on self-test firmware at when you go through production, and that firmware would have support for MCU manager writing to the key store, and then you'd write to the keys, and then a subsequent step would actually flash the production firmware.
You have a talk at EOSS, people might recognize a slide that said that exact thing, and it was borrowed from Mike. I may have been asking around the company for different ideas, and that was one of them. So, Mike also gave a talk. What was your talk about, Mike?
I gave a talk on code spaces, which I think we've shown off on the stream before. That's pretty fun. So they're based on dev containers, which is an open standard. And you just put like a .dev container folder in your repository. And VS Code will, if you want to run it locally, will recognize it and build a container based on the JSON file that's in there and run inside of that container, which is pretty cool. But for us, we use it for our training because we can have an entirely configured and usable Zephyr build environment in someone's browser, and it works across all platforms and browsers. So you just like load it up, takes like 90 seconds the first time for you to load up, and it's VS Code, but in a browser tab. I think the only hitch is it's not connected to your USB port because VS Code's running in the cloud somewhere. But we just have people download the binaries and use a local flashing tool to put them on the board.
Yeah, I think it's been pretty effective. It definitely shortcuts a lot of the struggles we had early on in training. So it is a small trade-off, and the fact that you could, I don't know, like you could go to the beach and still have your tool chain.
I was thinking about Mr. Robot, like Mr. Robot's like logging into some like USB key Kali Linux, and then like SSHing into whatever box he has set up somewhere in the cloud. And I'm like, I could borrow someone's computer and immediately build Zephyr programs. I'm such a hacker.
Actually, yeah, the previous version of the training software that we used, the Chasm, was kind of meant as that clean slate idea for the hacking community, where you could basically have like a desktop and a brand new Kali Linux instance each time you wanted to do something. But ultimately, I think the VS Code and code spaces thing is great, because then you also get access to it for whatever the 60 hours a month you get for free with GitHub. So that's pretty killer.
And people are generally very comfortable in VS Code already, and so if we just drop you into there, and like the nice thing is like it sets up everything so that the Explorer already has all the code samples that we're going to talk about in training on there, and you just like click and open a file and go.
Yeah, and after the training, you are encouraged to download the toolchain and set up everything on your computer and continue developing with Zephyr and Golioth.
Yep. Cool. One thing Marko talked about, actually, we were supposed to give some talks at the Zephyr booth. Those didn't quite work out because they didn't have amplification there. But one thing Marko actually has been working on is SMP. You want to talk about that a little bit, Marko?
Well, yeah, I can. Where do we start with the SMP?
What is SMP? So imagine you're talking to a completely clueless hardware person who's like, "What are you talking about?"
SMP is a simple management protocol, and it's used for it's a transfer encoding protocol that's used with MCU Manager to pass requests to devices and receive responses from them. And as you know, MCU Manager is a Zephyr subsystem that allows remote management of devices. And it's usually used for image management, file system management, and OS management. And obviously it uses SMP. And SMP is a application layer protocol that's used for device management, and for the transportation it can use serial, so UART, BLE, and UDP over IP. And I think that most of the folks in Zephyr land used SMP one way or another. So if you don't have a JTAG, you would usually flash so let me start again. There's an SMP server example in Zephyr that you can use to load your new image over serial, over UART. The problem is there is no SMP client, and in order to do what we are trying to do, and that is the multi-component OTA updates, so to have them as a first-class citizen in Goliath, we need some kind of a image management subsystem, and MC
Yeah, and so
Manager.
by multi-client, you mean one device that can push firmware updates down to other like child devices that are attached over UART.
Well, yeah, exactly. More often than not, products have multiple microcontrollers, and only on them, and only one is connected to the internet. Let's say Nordics 9160, and then you will have, I don't know, ESP32, STM, maybe 52840 for Bluetooth, also on the device. And the question arises how to push OTA downloads or new images on those, let's call them auxiliary microcontroller units. And SMP can be used as the transportation protocol. So what I did a demo, and basically I connected the Nordics 9160 DK to the 52840 DK over their UART1 port, if I'm not mistaken. And the 9160 DK downloads the image from the Goliath and transfers it over to the 52840, which then boots it up. So instead of with the MC Manager and the SMP server example, instead of using your computer as a client, as a host, you would use the 9160 or the main MCU or the connected MCU, let's say.
So did you write the client firmware then for that?
Well, yeah, all the code is available in Zephyr, in the management subsystem, but there is no example. And there's a lot of code.
Okay.
There's a lot of layers. So I needed some time to figure it out. Also, the demo, the example is available on Goliath Labs, and it's based on our firmware update sample.
I'm looking it up now. Ooh. That is the wrong Goliath. That's Goliath Labs with an A. And it looks like it's muscle, protein, and whey. All right.
You know, also things that we're interested in, just like getting swole, you know. That's actually Marco's alt account, you know.
Here it is. Multi-MCU firmware update. Yes. This is cool. I have not looked at this code yet. I'm excited. So here is labs code for you. And it's even got the diagram on how to connect everything. Yeah, this is great, Marko.
Yeah, it also has two patches. One is for Zephyr. So for the SMP server example, I just basically extended the sample to the 52840 DK board. And there's a patch for our SDK because our SDK is at the moment more tailored towards downloading and updating the image on the device that is connected to Goliath. So I removed the device rebooting and added some callbacks so I can call new functions basically from the application.
Does the controlling device store the binary as the blocks are downloaded, or does it just pass them straight through to the peripheral device?
Well, in my example, the 9160 would store the binary in its secondary slot.
Oh, interesting. Okay.
Yeah, and then it would transfer it.
Okay, so you could actually, I bet you could you do more than 2 slots with MCU boot? I bet you can.
I think you
It
can
depends
have
on your
different
flash
space,
size.
but yeah.
Right, but you can map it to external flash, I think. So like you could, like if you had 4 downstream microcontrollers, you could like add 4 auxiliary flash slots, and then you'd always have like the latest downloaded firmware stored there. That's kind of neat.
Yeah, exactly. Yeah, you could. I mean, not sure how. Just thinking in the moment. Yeah, it's a specific use case for this because and it's hard to make it general. So a lot of the code should be written in the application and not in the SDK because you can have.
Yeah, I think that's the same with like provisioning at manufacturer, like flashing a manufacturer, like it really depends on your use case. And so it's hard to be like, this is the way to do it and you shall not stray. Like all of these update things, like we have a good framework in place. And if you just want to use it, that's great. But if once you go outside of the lines and you're like, I have all of these, edge cases for my product, then you really got to think about like, what does my architecture need to look like to support this?
Yeah, exactly.
It's great. I can't wait to see a video about it, Marko.
Yeah, maybe we can do a demo here now live.
Oh,
I would love that.
I would love that too.
Hopefully it will work. Just give me.
Well, Marko's getting set up. I could talk through some of the things that I was going to show, but it's actually I've been troubleshooting a problem since. So we, Chris Wilson, our friend who does some of the reference designs for us, he wrote an article about the regulator subsystem, and I've been running into a thing where the 5-volt rail, which is a boost on the LED Elixir, which is the video that Marko just did introducing, it doesn't come up, and we're trying to power stuff kind of further down the line that is with this 5-volt boost circuit, and it just it's like no, I'm not gonna start, and so it does a cycling thing. One thing we found in that regular subsystem, which is interesting, is that you could add a delay, which I thought was taking care of it, but it seems like I think we found an actual hardware bug here, guys. So I'm gonna be on the bench later today. No, that's great. And that leads me to my the talk that I'll be giving in the Embedded Online Conference, which is the tools in Zephyr that help you to debug. So I'll be doing a whole talk about that, and like you said, later in today, utilizing them on the bench, because there are a lot of tools in there that help you to figure out what's going on.
I think I'm ready.
All right. I did a little jazz hands enough to get your setup going.
Yeah. If you want to put your screen to what you want to share, I'll add it to the stream. All right, you are now on the stream, and your screen is being shared.
Awesome. I'm only on a laptop, so I have one monitor, so I can't see you now. But as you can see, this is our Golioth console, and I created a release with 3 artifacts. So one package name is main, the other one is auxiliary MCU, and then there's auxiliary MCU 2. So we combined so we did one release with all 3 artifacts for our main microcontroller and 2 auxiliary ones.
Why 2 auxiliary?
Because why not?
Just to show.
Just to show that we can have. Just to show that we can have multiple artifacts for multiple microcontrollers.
Yeah.
And if we now switch to my terminal window, so on the left-hand side, I am connected to the 9160, and on the right-hand side, I am connected to the 52840. So if we check, okay, in the 52840, we can see that we only have one image available for us, and the same is with the 9160. Let's now trigger a release. Awesome. The 9160 is now downloading the image for the 52840. And so the 52840 is running the SMP server example. And if everything goes smoothly and correctly, it will boot up into the Hello World example. Awesome.
Now so the left side, the 9160 has received that in, and that's actually pushing the update down the line over UART.
Exactly. Got it. And now the 52840 is using the swap algorithm to swap the images, and we are booted into the Hello World example.
Wow, that was quick.
That was quick.
Yeah, it's a small image.
I was thinking that too. Like, wow, only 23 blocks. So in that case, was it you had all 3 releases bundled in there? Was it detecting that it was not getting all of them? Is that right?
Yeah, I can target which package name I want to release when I'm initializing and configuring Golioth firmware download, basically.
Aha, interesting.
So usually it's
and then
main.
if you if you made a release that just had one of the downstream artifacts, would the 9160 still download it?
Yes. Yes.
Oh, that's cool.
So it's a short demo, but it shows the
People can go try it
capabilities.
themselves, right? I mean, they can go and do it on their own.
Yeah, exactly.
And then what is the downstream device, the NRF52? What is it running in order to accept that? Does it have its own version of like the firmware update sample?
The 52840 is running the Zephyr's SMP server sample.
Okay.
So you have
And
to
then also MCU boot under the hood for
exactly,
swapping? Okay.
exactly. So it's a client server relationship. So the 9160 is the client, and the 52840 is the server. And as I said, when you're reading the SMP server documentation or the README, you would run MCU manager command line interface on your computer. You would basically do the exact same process, but in this case, the 9160 did all of that for us.
Let's go.
I love it. And then I'm also thinking about the transport layers for SMP. Is there a BLE transport layer for SMP? Oh, that's super exciting. Oh, we got to try that next. That sounds like a whole can of worms, though, as well.
Yeah, I didn't try it, but I think it is a can of worms. Yeah, but the thing also you mentioned, depending on the architecture, it would be good to figure out how or if to store the images that are downloaded to the main MCU or the connected MCU, or should there be a different kind of like OTA mechanism on with multiple MCUs?
Yeah, I mean, I'm sure we can figure out what we want, but still, once you get to the actual like production application, I think it's going to vary drastically. But wow, what a demo, man! Great job.
Well, thank you. And yeah, I think that we have to be general enough in our SDK not to tie our users' hands, but then again, we have to leave them the implementation in the application. So
Yeah, I was just
that's up
talking
to
to
them.
Marcina about this, and like he's on the same page of like giving the tools to the developers that they need, but then maybe having like a sample application that shows one way to use those tools, so that you can still customize everything as much as you need to, but you don't start from like you. The problem here is that there wasn't this example in Zephyr, so you started from like zero and had to figure everything out. If we can kind of shorten that path for everyone, I think it provides a lot of value.
I agree. And there's a lot of the abstraction layer of Zephyr is fairly big, so it's hard to figure out what's everything going on behind the hood.
Could you send me a firmware update so my browser stops crashing? That would be really great.
Give me a sec.
Yeah, right.
Switch to Firefox.
Yeah, maybe. Yeah, seriously. Thanks, Chrome, making me look like a slacker here. Like, I already heard Marko's demo. That's a big deal.
You're still on European voltage, so you keep browning out.
Yeah, that's probably what it is. Yeah. It's probably a hardware problem. As is the case in most of the things in my life. It's probably a hardware problem.
I don't know. I usually say it's a no. Actually, I do usually say it's a hardware problem. When I'm working on embedded, I'm usually poking around with all the bits and software, and I'm like, "What's going on?" Although, yeah, the one that I banged my head on the desk this week and blew at least 2 hours on. I'm writing a post for Tuesday about making a Bluetooth gateway and using it with Golioth, because we've been doing that stuff. We showed some hacks off, and it's nice to put that out there. And I went to stand everything up, and the NRF 9160 wouldn't talk to the NRF 52840, which is being used as kind of like a UART Bluetooth modem. And I kept having these timeouts. And when you get a timeout, then it asserts and crashes the chip and causes a reboot. And I'm like, what's going on? And I finally figured out there's more than one rev of the NRF 9160 DK. And they moved the reset line between the two chips between the revs. And I was asserting the wrong reset line. It's like, What an obscure
That actually was a
oddball
hardware
corner
problem there,
case.
huh? Yeah.
Yeah, well, I mean, hardware combined with software, right? So I was asserting a reset line, just not the one that was connected to the reset pin.
Yep. It's the effective same as pushing the wrong button. Is that right? It's not
Yeah.
W.
Oh, the other button, the one marked reset.
The reset
Oh,
button.
that
yeah.
one.
Right. Not the self-destruct button. Yeah, that'll do it. Well, at least you found it though. That's the important thing. When you do testing like that, what's your like debug process?
Well, you light your hair on fire and then run around screaming.
You did mention the desk and planting your forehead firmly onto it, right?
Yeah, in this case, we're flashing firmware. It's the HCI low power UART firmware from the Nordic tree onto the NRF52. So if you have a 9160 DK like this, it has. Let's see if I can do this backwards. I can't. It has the 9160 right here, but this is also the NRF52 right here, and you can use both of those. Like it's separate from all this debugging circuitry that's over here. And there's a switch right here. Right here to flip between which one's getting programmed. So it's like a really useful board. So you flip it to the NR52 and you flash the firmware onto there. So I was thinking, like, when I did this for the hackathon and I got it working, was I using a different version of the NRF Connect SDK called NCS version of Zephyr? So I flashed it a bunch of times. What I found out is if the 9160 was running and then I flashed the 52, it would all work. But then if I power cycled it, it wouldn't talk to the modem anymore. And like I could reliably do that every time. It's that made me think it was a reset problem, because I'm like, well, when I flash the 52, it's definitely resetting that chip, and it's probably resetting the 91 at the same time. And maybe that syncs the two chips up. And I saw in the overlay file that I was using a reset line on there. But what I didn't realize is like it's an include to do the reset line. And it just took me a couple hours to come around to the fact that there's more than one reset line option. And once I realized that, then it was easy.
That's good. Yeah, I think it's always the question for me. Like I think about like I2C kind of like debugging and stuff like that. So like usually the software, I'm watching the memory creep up. I definitely have a memory leak in this browser, so I'm probably going to switch browsers here in a second. If I'm not already frozen, just keep moving your faces, guys. Just smile and try to smile and frown. Then I'll know if I've crashed. Yeah, I like literally see it. It's creeping up like 0.1 gigabytes every second. So that's a memory leak. Anyway, yeah, in I2C, like I always think like it's just like not working. And then, you go and you look at like the debug messages to see if it's garbled. And then you dive down to the next layer and you're like, oh, can I decode the packets and look at it on like a logic analyzer? And then finally, like you get to the scope level view and you're like, all right, is the pull down actually pulling down? And then finally, like you go and like look and make sure the thing's plugged into the board. Like finally you get to the physical side, but like often the physical thing has the most impact in that way. Like things will definitely break if you're not resetting it properly.
Marko, didn't you go through that like 6 months ago or a year ago or something? I remember you having an I2C issue and you were like scoping the lines and you're like, I don't know what's going on.
I'm not sure if it was I2C or SPI, to be honest. But yeah, I did have some issue. I did have some issue that just trying to remember. There were multiple devices, multiple chips on the bus, and one chip was pulling one line low at some moment. I have to remember, but to be honest, with all the new technologies and Zephyr subsystems and everything that we have at our disposal, when I'm doing communication between two chips, I always hook up an oscilloscope.
Yeah, it's a good idea.
Actually. Check it. Yeah, and I always check it that way to see the timings, to see the lines, to see the rise up time and everything.
I had that on the Astentis, where I had plugged the Astentis into our Elixir, which if you don't know, that's like the display board and then our processing board. And like I was just getting these weird errors, like the Astentis wasn't coming up, whatever. And then I went to the I2C shell, which is one of our favorite debugging tool. That'll definitely be in my presentation. And it wasn't showing up. Like the address that I think it's 0x12 is the address, and it wasn't showing up. And finally, like I followed all these steps all the way down, and And then like finally I unplugged the cable and I realized I had smashed the cable in so hard that the the SCL and SDA were touching. And so it was taking on the whole bus. It was just like, that's what did, like that level of like, it was a stupid mistake, but like you had to go all the way down of just like, did I break something in software? No. Okay. As a physical layer all the way down to like finally like, yep, 2 pins touching. So, and that's bad if people don't know. You shouldn't have them. It's not going to work. All right. Anything else we should talk about with Embedded World or firmware or things coming up this week? Next week? Next week. It's Friday.
It is Friday.
Yeah.
The weekend. It's spring, so we're gonna get outside and not sit at our computers this weekend. That'll be
Wow.
nice.
Very proud. Well, I had a great time hanging out with Marko at Embedded World, and I'm sure we're going to be back at future events as well. We always publish about the events we go to, the things we hang out at.
I think you ran out of memory, Chris. I think he's gone.
I think he's gone for.
All right. Well, I think we can sign off for him. Marko, thanks for coming on. Great time. I'm glad that you were there to represent at Embedded World for Golioth. It's always wonderful to have you out showing all of the demos and hardware that you've been working on. And yeah, looking forward to the next great conference.
Yeah, thank you for having me on the Friday live stream, and it was great catching up with Chris on Embedded World, and looking forward to the next conference.
All right. Bye, folks. We'll see you next week.
Bye.